Hey, good morning, class, or good afternoon, class. Mr. Bean here, Astrophysics. This will be Unit 1, Lab Skills, video number 6, Night Sky Part 3. And this is using your left hand here. Now you have to hold it at arm's length, and this gives you a measure of degrees of the night sky. So like your pinky is 1 degree, a fist is about 10 degrees of night sky. 3 fingers here is about 5 degrees. This is 15, and this one here would be about 25. Let's kind of see how this applies to our situation. Go ahead and advance this. Okay, let's see. Okay, here we have the left hand again, 1 degree, 3 degrees, and 10 degrees. There's some background here. And again, 1 degree, 5, 10, 15. And here's the Big Dipper. So if you see the entire Big Dipper, you hold your hand out. This is the right hand now. This whole from this part here to American Doobie, this whole part right here is about 25 degrees. Big Dipper again. Here's another perspective here from the North Star and the whole Big Dipper here. So the entire Big Dipper is about 25 degrees of night sky. This is about 15 degrees, and the cup portion here is about 10 degrees. And between Merrick and Doobie, it's about 5-degree measure. Now, how is this all important to us? Well, a circle has 360 degrees, and there are 24 hours in a solar day. So the Earth's rotation with respect to the sky is 360 degrees divided by 24 hours, which is 15 degrees per hour. So this is what we want to use. Now, what does that mean? That means if you hold your hand up and your index finger here meets up with the star, in about 1 hour, the star will be over here. Okay? This is due to the Earth's rotation, the Earth rotating one way and the sky rotating the other way. So if an object is here, in 1 hour it will be over here, and it would have moved about 15 degrees. All right, so I'm not going to go ahead and read this to you. I'll let you go ahead and read this, and this should be review here. Okay, the prime meridian, latitude, the equator, okay, we should be familiar with this. Just in case if we need some reference here. Let's go ahead and let's kind of put this kind of over here for right now. And let's make this a little bit smaller. There we go. So just for reference here, show some features. Okay, again, here, okay, this is us here. This is the equator right here. And over here is the prime meridian. Okay. So this should be reviewed. Okay. Let's go back over here. Now it says here, refer to this globe on figure 1.4. We're asked to identify the equator, the prime meridian, 30 degrees north latitude line, and a 30-degree east longitude line. And this will be on Edpuzzle, and we'll go ahead and answer these 4 questions. Celestial coordinates. Okay. So astronomers draw imaginary horizontal and vertical lines on the celestial sphere to latitude. They're similar to latitude and longitude lines on the Earth. Okay. The celestial equator is a projection of the Earth's equator out to the sky. Okay, and now here's some information about right ascension and declination. So the best way to do this is, let's go ahead and do an example. So remember from previous class, we have to know what is our local sidereal time. So we'll go over here, and remember we have 119 degrees west, okay? And I'm gonna be like Thanos, I'm gonna go ahead and hit stop. So right now, our most important is that we know what our, here's universal time is important, but more importantly, we need to know what is our local sidereal time. Okay, that's what's going to help us out here. So the local sidereal time is 13 hours, 39 minutes, and 44 seconds. So 13, 39, 44. Okay, so let's go back over here. So we said it was 13 hours, right? 39 minutes, 39 minutes and 44 seconds. Minutes and 44 seconds. Okay, this is local sidereal time. Okay. Now, if we know what local sidereal time is, this is going to be our meridian. Right? This will be our meridian. Okay, here's our meridian. Okay, here's our meridian. And if I know the meridian, that's going to give us our right ascension of any star located on our meridian. Now, we are in Carson City, so we are, 119, hold on, we are 39 degrees north of the equator, right? Okay. All right, so way to do this here is, let's go ahead and do this simulation here. And let me go ahead and kind of slide it over here a little bit so we can kind of get out of the way here. And let's see what we got going on. So star position, okay, and let's see what we got. Star position. And we'll go ahead and hit pause real quick. All right, there we go. Got the right simulation now. And this is the observer's property. This is us. This will be us. So we're in Carson City. So our latitude will be 39 degrees north here, okay? And sidereal time. Okay, what's our sidereal time here? It is 13 hours and 39 minutes and 44 seconds. And we'll go ahead and put down 13 hours. So we'll go over, okay, down here, 13 hours. There we go. So this is, so this right here, so see this sidereal time? That will give us this blue line right here. That's the sidereal time, which is our meridian. It's also the right ascension of any star. So let's take a quick look here and see, this is 13 hours. Is there anything here that might be kind of close? Here is Arcturus. So let's take a quick look here and let's look at Arcturus here. Okay. And Arcturus is right now is 14 hours and 16 minutes and it's plus 19. So 14 hours. So right ascension is 14 hours. Okay. And its declination is 19 degrees. So 19 degrees. Okay. And so what we'll do is, okay, so here's the, okay, so here's us right here. So here's our meridian right here. And here's north right here. And so, right, let's see, 14 hours. Okay, so real time. So we're about to show the, so this is our meridian, and the Arcturus is 14 hours, so it's over here. So this is, remember, this is this would be 13, 14, 15, 16, 17. If this is 13, then this would be 12, 11, so on and so forth. So here's where it is right here, and the star is, so here's our zenith right here. So it's a little bit, so we're at 30, this is 39 degrees right here. So let's get a, let's go ahead and mark this right here. So this is, okay, let's see what this is. Let's go right to here. So this is 39 degrees right here, and our Arcturus is 19 degrees. So we're off just a little bit right here. All right, so that's a good way to talk about using the local sidereal time and the celestial coordinates. Okay, let's go back, continue on with the video here. Okay, so let me go ahead and erase this real quick, and you guys go ahead and try to answer some questions here. So using this figure here, give the location of the star. So here's the star right here. And you want to go ahead and give me the right ascension and declination of this star right here. Yeah. Okay. Local reference lines. Okay. Again, this is our meridian here. This is our zenith, and this is our horizontal plane. Horizontal plane. Should be able to answer these questions here. Earth's seasons. Okay, so we are fairly familiar with the seasons, and we should know that the Earth's equator, the Earth is tilted 23.5 degrees. Okay, so if this was the Earth and it was straight up and down, that would be like 90 degrees. It rotates like this. However, the Earth is slightly tilted. So we'll go like this here, and we'll put this down here in the middle like that. This is 23.5 degree tilt. And more importantly, the Earth, if you took a rod to the center of the Earth, the North Pole, if you would extend it, it would go ahead and point to Polaris, which is our current North Star. Polaris. Okay. You take a look here. So here's June. The northern hemisphere is tilted toward the sun, so we have summer, and then equinox is coming up pretty soon here. And in the wintertime, the northern hemisphere is tilted away from the sun, giving us a winter. And we're going to erase this here real quick here. Use it in the next video. Okay, our next slide here. So our next slide, again here, answer this question here. Refer to figure 1.11. Go ahead and answer some questions. Equinoxes and solstices. Go ahead and do a quick read on this. Okay. All right. So this is called a flat sky map. It is tracing out the path of the sun. Okay. So September 23rd is right here. So we're kind of like over here, getting ready to come here. So the sun's tilt is going to be about 0 degrees. Okay, December 21st, which is D, is going to be negative 23.5 degrees because it's tilted away from us. Then back in March 20th, at the equinox, it's back at 0. And then on June 21st, the Earth is tilted toward the sun, which will give us a positive 23.5 degrees. And then we'll roll right back into the autumn equinox here. So we should be able to identify the 4 major regions here. Okay. Precession is called wobble. Okay, so the Earth is being tugged. So over here we have the sun. The sun is here, and we have over here the moon. So here's the moon. The Earth and the moon are pulling on each other. The Earth and the sun are pulling on each other. So it causes this to wobble. Okay, it causes it to wobble. So currently, right now, our North Star is Polaris. So for it to go all the way around is about 26,000 years. That says 25,500. So to go from here and all the way around is about 26,000 years. Now, when the zodiac was first developed, Thuban was the North Star when the zodiac was first developed. So zodiac. Okay. And so because of this precession, we now have a new North Star. And in about 14,000 years, Vega over here will be our new North Star. This will be, it says here, about 14,000 years. So roughly 14,000 years from now, this will be our new star. All right, go ahead and answer some questions here, and that will conclude video 6.